Good morning. Happy Wednesday. Good morning. Welcome. Good morning. Hope you're all having a great morning. Hope everybody did advisory. We have new lessons today. Hope you all did your do now. So good morning. Good morning. Hi, honey. Good morning. Only a couple people have shown up so far. This was your do now, volume with fractional edges. So we'll talk about this today. So you should have already done these two problems. That was part of the assignment. Remember, if you're not clear on your assignments, they are always posted on Instagram. They're always posted in Teams and in Canvas. So there's multiple ways. Good morning, good morning. So there's multiple ways to see what the assignments are. So again, this was your assignment for the do now. We've talked about how they call it the opening. This is day 1 of week 5. It's a combination of our Eureka lessons from module 5. Okay, it's on, for me it's on page 2 of the math packet, but you guys have it all in a bigger packet. Good morning. So, if you have this packet, it's the one with this rectangular prism on it. And we're going to be talking about volume with fractional edges. So they're going to take a skill that you learned in 5th grade, which you may or may not remember. You would have learned, good morning, good morning. You would have learned volume, basic volume in 5th grade. For example, the volume of a cube or rectangular prism. So what makes it a 6th grade skill now is using fractions as our distances or lengths of the sides. So, because then that uses our 6th grade skill of multiplying and dividing fractions. So, volume with fractional edges, that's what that means. Good morning. People have all jumped on and then jumped right off. So, remember, 4th quarter does matter. It matters especially if you feel like you didn't do your best in other quarters. So, it really matters if you're an avid or want to be an avid, if you're not doing the work. We're tracking all of our attendance and work. So I received 1 exit ticket from Monday. Good morning. Just 1 from a new student. So 4th quarter matters, and we can't, slack off on the work. Okay? So everybody should be at the right page now. Again, it's the week 5, day 1. We're talking about the volume with fractional edges. So volume, like I said earlier, is a 5th grade standard, but what makes it 6th grade is using fractions as the lengths of the sides. So, by the end of today's learning, I will extend my understanding of volume. That's why it says extend my understanding, because they're reminding you you've already use this skill in earlier grades. For some of us, it may be the first time, so we'll take it a little slow. My understanding of volume to include side lengths with fractions, apply the formula for the volume of a rectangular prism, and be sure to answer with appropriate units. Good morning, good morning. Sorry, I'm trying to wave at the same time. So, this was your do now. It only should have taken you a few minutes. They asked you to use the unit cubes to build the figure to the right. Sorry, my screen just froze. And fill in the missing information. So I'm just going to go over it quickly, just so you can know what to do. If you hadn't done it yourself, you can do it later with number 1 and 2. So when they're talking about the number of layers, okay, they're talking about the levels from, bottom to top. Okay, so type into the comment, how many layers do you see in this rectangular prism? Go ahead, somebody just type in the number. How many layers did you put in this rectangular prism? Good morning, good morning. Good to see you. We're on week 5, day 1. We're talking about volume. Good. Thank you. So there's 2 layers. Somebody's typed in. We're not talking about how many cubes in the whole thing. So we're talking about how many layers. So this would be a layer. This would be a layer. Okay. Then it asks the number of cubes in each layer. And that's where they want you to take a closer look. And you would be thinking about how many you see in the front, but you also see part of them on the side. You know, think about looking at like a Rubik's Cube. You know, you can see how many pieces are on one side, but you can also sometimes see the side of it. So, oh, people are putting in that answer for you too. Yeah, so the number of cubes in each layer, if there's 3 on this side and 2 on the other side, 2 times 3 is 6, so people have put that in. And then you'd find the volume of the whole piece, okay? Now, that's really practical when you can see the cubes, you know, like in a Rubik's Cube or in a rectangular prism, you know, when they show you the squares. But for us, you know, now that we're in 6th grade, we're typically going to get a picture like this on a park test or on a test. Same in 7th grade. Good morning, good morning. And we're going to need to figure it out using measurements. We're not going to be able to draw squares and just count them. Okay, so today it's going to take a little bit of time to go through the notes. There's a lot of notes, and I want to make sure you understand, because even where they show you how to do the work, they've not necessarily shown the steps of how they got that work. And I also want you to remember on some of these, they would be in a calculator section. So if we're using decimals, you can use your calculator if you have a separate calculator like we talked about the other day. That's handy to have in this unit. Just an extra calculator that's not on your phone if you have one. Okay, so they're reminding you in 5th grade, you learned how to calculate volume by determining the area of the base and then multiplying that by the number of layers. Okay, so that's actually what you just did when we did this. We found the area of the base, that base layer, and then we multiplied it by how we found that the area would be, we said 2 times 3, that would be 6. And then in this case, you multiplied it by how many layers there are. So that's a way of breaking down what they're saying here. That's how you learned it. Sorry, it says my connection is bad, so I apologize for that. Hope you can see me. I'm not sure why I'm getting that message today. So, this is an equation for volume with a length times a width times a height. Remember, we can put all the variables right next to each other. We don't need any multiplication symbols now. Good morning, good morning. You know, now that we're getting ready and doing algebra, we don't need little x's. We don't even need the dots anymore. We can use these parentheses when we put numbers in. So we're going to review how to find the volume of this shape. Okay? So we've talked about, even with triangles, that, you know, sometimes the longer side is normal to call the length, and the shorter side you would call the width. And then obviously if you're going up from those, you know, at a 90-degree angle, you're going to have your height. So what they did here, to remind you of how to use that formula that you used last year, and again, the new step is that it's using mixed numbers, which have fractions in them. So they're assuming that you remember how to turn these mixed numbers into improper fractions and then multiply. Okay, so that's where I want to slow it down a bit so that we make sure that we're understanding that. Okay, so if we have 6.5 inches, who can tell me what number goes on top if I'm turning 6.5 inches into an improper fraction? Okay, so if I'm taking 6.5 inches, you don't need to tell me the denominator, because I already know my denominator is going to be 2, right? But how do I turn 6.5 inches into an improper fraction? Because they're giving you answers, but they're not showing you the work to see how you got these numbers, and we need to know how to do that in order to move forward. What do you do if you don't have the packet? Well, another way you can look is it's on Teams, and it's on under the files in Canvas for your class there. The whole packet, it's in its entirety. We're on day 5, and this is, week 5, and this is day 1. Week 5, day 1. Sorry if I misspoke. Okay, somebody said 2. Somebody said 13 over 2. Great. That's right. Because remember, you're taking 2 times 6, which is 12, and then adding the 1. Good morning. People are still jumping on. So you get 13 over 2. Okay? So I have 13 over 2. What's the next one? Who wants to give me that one? And again, we already know our denominator. And this one is 3 inches. If we're taking 2 1/4 inches and we're trying to make it an improper fraction, what do we do with that? Okay, if you don't have the packet because you turned it in, it's okay. It's week 5, day 1. You can get another copy by downloading it from Teams or looking at it on Teams, looking at it on Canvas in your class in Canvas, or you can DM me or email and we'll email another copy. There's plenty of ways, so don't panic. You can just do the work on paper just like we've been doing. Okay? Yep, some people have been doing that all along. Yes, you could do it on paper. You just take a picture of it at the end and DM me your work. The problem is some of you aren't doing the work ahead of time and after the exit tickets. You're just DMing me what we did in class. That's class work. So although you get credit for being in class, then you're not getting your points for your exit ticket and your due now, and those are the grades that are going into the grade book, the things that you have to do on your own. So we want to make sure we're actually doing work that we're not just all doing together. Okay? So somebody said 9. Okay? So this is how you would have it set up. If I have the whole number 3, what's my denominator for the whole number 3? If I want to turn it into a fraction, just type it in to the comments. What denominator do I give it so that I have an equivalent fraction that's equal to 3 inches? Okay, and I've given you the hint here. Good morning. How do I turn the whole number 3 into a fraction so that I can multiply fractions? Great. Great job, honey. Okay. She said put a 1 under it. So we have our length, our width, and our height in fractions. Okay. That's the step they jumped. And then you're going to multiply numerator times numerator times numerator, denominator times denominator times denominator, and then we're going to have to reduce it if it's an improper fraction. Okay? So 13 times 9. Most of us didn't memorize our 13s. Sorry, I don't know why it says my connection's bad today. We have a lot of people in our house using the Wi-Fi, so I apologize if there's any breaks in the video. So 3 times 9 is 27. Carry my 2. 1 times 9 plus 2 is 11. So I have 117. But then I have to still multiply it by 3. And you can use a calculator if you have it, but not everybody had one, you guys said. So it looks like I got 351. If anybody wants to check my work and tell me if that's correct or incorrect. What's the next step? You can type it into the comments, our next step. Again, I'm walking through the notes because it assumes you remember how to do a lot of things that we haven't done in a while. Good morning. Good morning. Good morning. Okay, good morning. The next step is we have to multiply the denominators. We just multiplied the numerators. Now we have to multiply the denominators. 2 times 4 is 8. 8 times 1 is 8. So I have 351 eighths. We obviously know that's improper, so we're going to have to do our division. Okay? I'm going to do it as long division because we're doing fractions. If we were doing decimals, then I might resort to the calculator. I need to know how many times 8 goes into 35. Remember our Does McDonald's sell cheeseburgers? Okay, that's our device that we use to remind us how to do the steps of division. I would say 8 goes in, yep, somebody's putting the answer in. Okay, 8 times 4, I'd get 32. That's my multiplication step. I'm doing my subtraction step. 5 minus 2 is 3. 3 minus 3 is 0. 3 is smaller than my divisor of 8, so I'm going to bring down the 1. Now I have 31 divided by 8, so I'm back at my division step. I want to see how many times 8 goes into 31 without going over. Okay, here I know I multiplied it by 4 and got 32, and that's bigger than 31, so I'm going to have to bump it down a number and do 3 times 8, which is 24. Then I'm going to subtract. I can't do 1 minus 4, so I have to borrow. I borrowed 10 from my neighbor next door. I have 11 minus 4 is 7. 2 minus 2 is 0, and you can put the zeros if you want. So now I have a remainder, which we know becomes my numerator. And I get my denominator from my divisor. And I get 43 and 7/8. And we're going to see that that's how they got this number. Okay? So they jumped way ahead of us by not showing everybody or reminding everybody how to get this number. So it's not magic. It's a lot of work. This is all the work just to get this answer, even though they wrote all this. You know, that looks really easy, but this is why it's a 6th grade level problem now, because you're doing multiplication of fractions, you're still doing long division, you're still using improper fractions to solve problems. So there's a lot going on, and that just shows you guys how much you've learned. Okay, that shows you you're ready for 7th grade because you're able to do all of these steps in a problem. You know, these problems aren't just a one-step problem anymore, they're multiple steps. So a box with the same dimensions as the prism above is used to ship miniature dice whose side lengths have been cut in half. The dice are 1/2 inch by 1/2 inch by 1/2 inch cubes. Okay? So they want to know, and that's why it's in bold, how many dice of that size can fit in the box, right? This is the box. And they're going to put dice in it that are 1/2 inch by 1/2 inch by 1/2 inch. Now, I got out my ruler to remind us, because a lot of these problems are using 1/2 and 1/4. Okay, so here's 1 inch. Okay, this is on the conventional side of the ruler. This is the centimeter side. Okay, this is my side with inches. So my inches, sorry, there's a shadow now. My inches would start at this line and go to here. Okay, we've talked about all year when we reviewed measurement that we count inches, we count the little pieces are 1/16. How do we know that? Because when we count them, and we're not going to do all that now, we count them, there's 16 of them. Okay, and 16 out of 16 gives us the 1 inch. So we also talked about 1/2 inch then is halfway between where this line starts and the 1. So they always have half marked, and then they have the quarters marked. Remember, there's 4 quarters in a dollar. There's 4 1/4 in the whole number 1. So they want to use a die. Die is the singular of dice. They want each of the dice to be 1/2 of an inch. Okay, 1/2 times 1/2 times 1/2. Okay, so that's what they're talking about now, because when you read it, it's a little bit confusing what it was asking you to do. So the first thing you need to do, it says, is determine how many miniature dice with a 1/2 inch side length fit inside a cube that is a 1 inch. Okay, 1 inch by 1 inch by 1 inch. Okay, so that's why I wanted to show you on the ruler. So they're showing if you had a cube that was 1 inch by 1 inch by 1 inch, they want to know how many, good morning, how many of these miniature dice would fit if they were only 1/2 inch by 1/2 inch by 1/2 inch. Okay, so that's what this picture was that they were trying to illustrate. And again, I just want to talk you through it. So it says, I can see that 8 of the miniature dice with 1/2 by 1/2 by 1/2 would fit into the cube with 1 inch side lengths. Okay, so they're showing you if it was a 1 inch cube and you had the little miniature dice that were only 1/2 by 1/2 by 1/2, their length times width times height, they're showing you you would be able to fit this first level. You'd have, 2 on this side, and you'd see 2 on this side, and 2 times 2 is 4. So you'd have 4 on the bottom level. They were calling this a level. This row would be 4, and then up above it, you would have 4 more. Okay, and 4 plus 4 is 8. So that's where they're getting the number 8. Okay, so 8 little dice that are 1/2 cubed fit in a 1 inch cubed box. Okay, but they want us to use this size box that we started with. Okay, and we got this answer, 43 7/8. They want to see how many of these dice would fit in that. Okay, so that's where they got some of these numbers. So 43 7/8, okay, they took it and they went back a step. Okay, remember, before we got to this point where we found the length times the width times the height, before we got to the final answer, we had a fractional version of the answer. Good morning, good morning. We had a fractional version of the answer. Okay, we started with an improper fraction. So they're going back to use that improper fraction because these are equivalent. 43 7/8 equals 300. Again, sorry, it says my connection's bad. Apologize. I'm not sure why my phone is charged. Maybe because, like I said, everybody in the house is online at the same time. So they're taking 351/8 and multiplying it by 8. Why by 8? Because they said in every 1 by 1 by 1 inch cube, right, there were 8 little dice of this size. Okay, so they're taking the whole big cube, it's not even a cube, sorry, the whole rectangular prism, this whole box, and trying to see how many of these fit into it, and therefore how many of the little dice there are. Okay, so 351/8. Again, if you took 43 7/8 and divided it by 1, you'd get 43 7/8. So that's why this number stays the same. So for every 1 inch of the 43 7/8 inches cubed, you can fit 8 of the little dice. So to make 8 a fraction, they have to put it over 1. They're also reminding us the skill we learned in 5th grade and 6th grade, where we can divide out the 8. 8 divided by 8 is 1. 8 divided by 8 is 1. Because there's an 8 on the top of one of the two fractions and on the bottom, we can make them an equivalent number 1. So then you end up with 351 over 1. Okay, so again, just to visualize that, if we have the 351 over 8 times 8 over 1, this is what they did. 8 divided by 8 is 1. 8 divided by 8 is 1. 351 times 1 is 351. 1 times 1 is 1. 351 divided by 1 is still 351. That's how many little mini dice this big would fit in this shipping container. Okay? Now, I know that's a lot. It's okay if you're late. Thank you for joining us. Good morning, good morning. Okay. But that's why I told you to read the notes ahead of time. That's why we always tell you to read the lesson ahead of time, because it's a lot to try to visualize, and we want to be able to walk you through the steps. Okay? So, that's a lot. That would all be one problem on a PARCC test. Okay? It would be a two-part problem, because you'd be finding the volume of whatever container they wanted, and then they love to ask how many of a certain size of cube would fit in that bigger piece. And some of you that came to Saturday schools when we prepped for PARCC may remember some of those problems we did. Okay? But just like we always do in Eureka, we always want to think about another way to solve the problem. Okay, there's more than one way to solve problems, and it's great to have more tools in our tool belt. So we can think about that problem another way, and they're going to show us here. That's what they did on the next page. So it says, instead, we can see how many mini cubes with a 1/2 inch side length will fit across each dimension. Sorry, my phone again. Then we can multiply each dimension together to see how many mini cubes there really are. Okay? So this is the same box that we had in the original problem. Okay, those are the measurements. And they're saying, oh, well, you could just take each of these measurements and divide it by 1/2. And then figure out how many cubes you would see here, how many you'd see here, how many layers you'd see, and then you can multiply those together. Okay, so that's the other way. So again, it goes back to why they showed us two different ways to solve these problems in the do now. And if you do the do nows, then this all makes more sense. So that's why it's important to do our pre-work. Okay, so here they've taken, and it got cut off a little bit, 6.5, and they've divided it by 1/2. Now again, they're just assuming you remember all the steps to make that happen. That's nothing you can just do in your head. Okay, and that's part of the issue with turning in packets. A lot of people are turning in packets that have an answer, but then you're not showing me where you got that answer. And if I can't do a certain problem in my head, then I know you can't do it in your head. And we've learned we're not really doing anything in our head except some of the, easy fluency stuff. So if there were 13 of these, where did they get that number? Well, again, they took the length, 6.5, and divided it by 1/2 inch. Again, you could draw a model for that. Good morning. That would be a more basic way to do it from earlier grades. The 6th grade method is going to be to find the improper fraction. 6 times 2 is 12, plus 1 is 13. So my improper fraction for this is 13 halves divided by 1/2. Now, something special we learned this year that not everybody learns, I don't really think I learned it till I was an adult, is that in division, we've talked so much about we don't really divide fractions, you always multiply by the reciprocal. However, we learned this year, and again, it makes life so easy, that in division of fractions, when you have the same denominator, you pretend there's no denominator and you just divide the numerators. Okay? These both have 1/2 as a denominator. So, 13 divided by 1 would be 13. That's where they got the 13. Now, could you still do it with keep, change, flip the way you guys said you learned in 5th grade? I call it multiplying by the reciprocal. Sure. But this is a faster, easier way. Okay? So that's where they got 13 little mini dice would fit along this side of the box. Now we have to check on the side that's... Oh, they're giving you the answer. 2 1/4. Okay? Sorry. So 2 1/4 divided by 1/2. 2 times 4 is 8, plus 1 is 9. We have 9/4 divided by 1/2. Are those the same denominators? No. So, type in the comments, what should I do? Okay, we're not going to be rude to each other. We're not going to be disrespectful to each other. If you're not here for the math, you're free to jump off. Let's use our time wisely. We're all getting ready for AVID. We're all getting ready for 7th grade. Term 4 matters. We're not going to, play petty games in the comments, please. Okay, so who wants to jump on or tell me in the comments how to solve this? They don't have the same denominator, so what could I do? I've just reviewed the 2 ways you could do it. Good, I like it. I like it. Okay. So, one of our advanced students, one of our new students, is saying, great idea. That was one of the ways. You can turn this half, oh sorry, I circled the wrong half. We could make it fourths. So they have the same denominator. And 1/2 is 2/4. So then we just have 9 divided by 2. If they have the same denominator, you don't do anything with it. We just have 9 divided by 2. Okay, and we'd get 4.5, which is correct. Or, remember, your deans are watching, so if you want to make inappropriate comments, I'm sure that you'll hear about it later. The other way, okay, that was a great way. Thank you to our new students. You're contributing a lot. I really appreciate you. You're doing a great job. Is you keep the same improper fraction you start with. You change your division to multiplication, and then you multiply by the reciprocal, right? The reciprocal of 1/2 is 2/1. Now, you could also reduce something ahead of time, but I know that sometimes gives more mistakes. Ladies and gentlemen, if you don't have the maturity to be on my class, then I'd really prefer that you jump off. Okay, I'm sorry to even have to say that. You know, there's parents on here watching too. It's not just children. So, okay. So I have an improper fraction, 18/4, because when I multiplied the numerators, 9 times 2 is 18, 4 times 1 is 4, and then I'm going to take 18 and divide it by 4. I don't do any of this in my head. Okay, it's fractions. I know 4 goes into 18 4 times without going over. 4 times 4 is 16. 8 minus 6 is 2. 2 is smaller than my divisor. So I make that my numerator. I make my divisor the denominator. 2/4 can actually be reduced. Okay, I know they're equivalent to 4.5. But remember, again, another skill before 6th grade, reducing these fractions. 2 divided by 2 is 1. 4 divided by 2 is 2. So that's how we know that it's still 4.5. Okay? So, we have our 13. We have 4.5. And then we have 3 divided by 1/2. Okay? 3 divided by 1/2. So, I make the 3. I can make it a fraction. Divide it by 1/2. I'm going to take it, multiply by the reciprocal. 3 times 2 is 6. 1 times 1 is 1. 6 divided by 1 is 6. So that's where they got their 6. Okay, so they make it look so simple. Oh, 3 divided by 1/2 is 6. But, you know, I really want you to see where, remember, we don't say shut up. Educated people don't use that kind of terminology. Same rules apply as I have in my classroom online. So please stop. Okay, so that's where we get 13, 4.5, and 6. That's how many little cubes would be lined up here. Okay, on this side you'd see 4.5 lined up, and then up you would see 6. So that would be your length times your width times your height. Okay, so that's what they did here. 6 times 13 times 4.5, and they got 351 mini cubes. Okay, same as we got here, the miniature dice. Okay, so these little ones, 1/2 times 1/2 times 1/2, they've shown you 2 different ways to do it. You can either divide each side by the size of your mini dice and then multiply those length times width times height to find your volume, or you can take the whole volume of it and then figure out how many are in one and multiply it. Okay, so there's two different ways. It's a lot. Okay, it's a lot. Now the other skill that they want us to do today, and again, we haven't even started doing these on our own yet. It's a lot. So it says, what if the miniature dice had side lengths of 1/4 inch? So remember, here we used a 1/2 inch. Those were half, although you can't see the half necessarily well. How would that change your answer? Okay, so now they're saying, we just did it with a 1/2 inch, which is halfway from where I start to 1. Now what would happen if I reduced it to 1/4 inch? So 1/4 inch would just be these lines here, right? Up until this line that goes in between the N and the C. That would be 1/4 inch. How many dice that have 1/4 inch by 1/4 inch by 1/4 inch would fit? Okay? So, that's what they're talking about here. Well, the way to figure that out is how many of those 1/4 inch cubes or dice would fit in your 1/2 inch, right? That's what they want you to think about in your mind. That's why these pictures are important to have when we're talking about these notes. Okay, because geometry is difficult for a lot of us to visualize what they're talking about. And so when we have these concrete examples, if we were in the classroom, we'd have some more, manipulatives that we could use. So they said, I would be able to fit twice as many cubes for each dimension of my original box. Therefore, the number of cubes would not just double. It would increase by a factor of 8. Okay? So if you're doubling how many you have on each side and its volume, that's why then if something's doubling and times doubling and doubling, that's where they're getting the 8 from. So instead of having just 351 mini cubes, okay, they took 351 and multiplied it by 8 and are saying you would get 2,808. Okay, I'm going to ask one last time to please stop. If you're not talking about math, or I'm not asking a question and you're not asking a question, we shouldn't be typing any comments. Okay, so now this is referring back to a skill that we reviewed at the beginning of this lesson today that they said that you learned in 5th grade. That sometimes it says you'll see volume. Hang on. It's going to join us.
Hi.
Good morning.
Listen, I am so sorry to interrupt your lesson, but I'm going to say this one time. I am screenshotting the comments and I'm going to be texting your parents your inappropriate comments. So I suggest to you that if you are not answering or asking a question about the math that is taking place, that you keep your fingers to yourself. Does anyone have a question about what I just said?
I told you guys, teachers are watching. Ms. Mixon's always here. The principal's here sometimes. The deans are here. The APs are here. So you don't know who else is watching. Parents are watching.
So now I'm screenshotting. And then I'm going to text it to your parent. And you can explain to your parent, oh, this is probably why you don't have an A in math class. Thank you. I'm so sorry to interrupt, Ms. Martin, but
Ms. Mixon, I really appreciate you because I know there's kids on here, there's students on here that are trying to get into Avid next year and stay in Avid, and they're actually doing a lot of work. And even some of the kids that aren't in Avid know that if they do a really good job this quarter, that's going to matter for getting into Avid. But there's other kids that just sound like they're just trying to you know, disrupt and not really pay attention and aren't really that concerned about how term 4 actually matters for their grades. So
Exactly.
thank you.
Oh, you're very welcome. I'll talk to you later. Bye.
Thank you. Okay, so I think we've been clear a couple different times now. Okay, so sometimes in a problem, they'll refer to the area. Sorry, my phone keeps saying there's a bad connection. They'll refer to the area of the base. Okay, we represent this in formulas, okay, with a capital B. Okay, a capital B means that the area of the base has already been calculated. Since a rectangular prism has a rectangle as a base, this just means we know how many cubes are on the bottom layer. Okay, so they're just reminding you of what that means. So when you're finding volume, you're still using the formula length times width times height. Okay, the formula hasn't changed. Oh, excuse me. The volume is length times width times the height. Okay, and I'll just put the dots there to remind us, even though we don't need them anymore, that we're multiplying. But remember, the area of a rectangle, right? The bottom of these shapes are rectangular prisms. The area of a rectangle is length times width, right? So they're calling that the area of the base with a capital B times the height. So if you already are told in a problem that you have the area of the base, then you don't have to do this part of the problem, the length times the width. You just have to take that area of the base and multiply it by the height. Because if you have the area of a rectangle, you've already done the length times the width. Okay, so that's what this part means. When they say the volume is the area of the base times the height, this is where that comes from. In a rectangular prism, the base is a rectangle. So you've already found the area of the rectangle if you've already multiplied the length times the width. So then you just have to put that area and multiply it times the height, and you get the whole volume. Okay? So this is what they're talking about in this example. Here's another example of a problem you might get on the PARCC test or on a unit test. Okay? And again, remember, I think we have a test coming up in a couple weeks, so we need to be ready for it. The area of the base of a rectangular prism is 7.5 meters squared. Okay? So they just called out that it's the area of the base. Even if you didn't know that, what in this measurement tells you that you have an area? You can type it in the comments. What clue in this area, in this answer, tells you that you already have area? How do I know from looking at this number? You can type it in the comments. How do you know 7.5 meters squared is an area already? How do you know? Type it in the comments. Don't just copy somebody else's answer. Type it in the comments. I'll just wait. You know, we had to lose some time because people were doing inappropriate things. Great. Thank you, dear. You can tell because of the units, okay? Because it's meters squared and area is always squared. Thank you, ladies. Nice job. Because it's meters squared, we know it's area, okay? So, besides the fact it said area of the base, if we were reading too fast, that's the other way to know. Great job, okay? So, we have the area of the base and the height is 3 3/4 meters. You'll have to note there's no meter squared. So that's not an area, that's just a distance or a length. Determine the volume of the rectangular prism. So they've rewritten it for you, that the volume is the area of the base. We said that would be a capital B times the height. They took the 7.5 meters squared and are multiplying it by 3 3/4. Okay, this time they showed you the improper fractions, but they didn't show you how you got them. So remember, 2 times 7 is 14 plus 1 is 15, and you keep the same denominator. 3 times 4 is 12 plus 3, and you keep the same denominator. Again, I would call people on to answer the question, but I know we had to waste some time with behavior stuff today, and I hate to do that and take time away from kids that are really trying. So our volume is 225 divided by 8, right? Remember, a fraction is just a division problem. So 225 eighths is the same as saying 225 divided by 8, okay? And yes, I would have to do that with a long division. I wouldn't do it with my calculator because we're not doing decimals. And they got 28 1/8 meters cubed. Why is it meters cubed? Someone tell me. Good morning. Someone tell me in the comments. Why is it meters cubed all of a sudden? I can wait. Why is it meters cubed? I'll wait for you. Good morning. I'll wait for you to type it in. You were given the area of the base and the height. So instead of using the formula volume equals length times width times height, we multiplied the area of the base times height. Okay, so we used this formula instead of this one. So why is our answer cubed? Meters cubed. Okay, somebody's saying it's being measured by meters, by cubic meters. Okay. When we found this area of the base, okay, when we talked about this was meters squared because it was area, how many things did we multiply together? How many lengths or distances did we multiply together to get meters squared? How many things are you multiplying together to get the area of the base? You can just type the number in the comments. How many things are you multiplying together? Okay, let's even go back to the one, that original cube they gave us. 1 inch times 1 inch times 1 inch. We'll make it really simple. Good, somebody has it. I want to see more people with the answer though. When we're finding the area of something, okay, you're multiplying two things together, a length and a width. So that's why you're multiplying something that's meters times something that's meters, you get meters squared. When we're doing volume, how many things are you multiplying together? How many distances are you multiplying together? Good. So in this case, 1 times 1 times 1 is 1. But remember, inches times inches times inches is inches cubed. Remember, each of these inches, there's the invisible 1 up at the top. It's like an invisible power of 1. And when you multiply the units times each other, it's like you're adding those ones together. Okay, we talked about that with area of a triangle when we got squared. And so that's why it's meters cubed, because it's 3 original distances that are multiplied together. Again, sorry that keeps pausing. So we've gone over our time a little bit. I hope our behavior can improve for our next class. Okay, I want you to try number 1. They have done a lot of the pre-work for you. Okay, you're going to do number 1 and number 2. okay, before the next class. You're going to do 1 and 2 before the next class. Okay, so I'm really excited that some of you are really taking the time to join these classes and take it really seriously. Again, I want to welcome the new students. You've been a great addition and you're really working hard and I really appreciate it. Yes, class is over. Sorry, guys. Some people said it went by fast. It was a lot today, a lot of notes, and not so much of you guys participating necessarily, but we will have more of that on Monday as we continue this lesson. But this is really important information, so I don't want to just glaze over it and have you misunderstand something that they're doing, because even though they've provided you with some good structuring and scaffolding and parts to help you, you know, it's not necessarily all there. So I'm available for help. Ms. Mixon's available for help. Remember, there's still after school all-stars for people to get help. There's no excuse not to get help if you don't understand something. Okay, so you're going to do 1 and 2. I'll put that in the assignment and we will move on from there. Okay, yes, it's week 5. It's still day 1. It's the part that says your turn. You're going to do number 1 and 2. If you need help, then ask for help. We will go over that on Monday and we will move on from there. Okay, but we're not going to just race through the packets just to get them done. We have to understand what we're doing. This is all new material. It takes time. Okay, so please have a great day. If you need anything, please let me know. You can DM your pictures of your work. You can email it. Call me. People have called me if you need help. Text me, however you want to reach me. Okay? I appreciate those of you that are working hard. And if you're not one of those people, please reflect on what's important to you and whether you want to be ready for 7th grade. Okay? Thanks.